afternoon. I'm Elisa Garcia, and I lead the startup program as part of the Microsoft Quantum Network, and it's really exciting to be here with my peer Ben today.
I'm Ben Porter. I'm Director of Business Development for the Microsoft Quantum Computing Group, and this is going to be a great tag team event here. Hope you're excited here. I know you've heard a lot today already about algorithms and introduction to quantum computing, what the right application areas are. We're excited to share with you the stories of our partners and customers and the work that we've been doing with them.
So for us, it all starts with Azure. We have more than 95% of Fortune 500 companies using Azure right now. But it's not only Fortune 500. More than 10,000 customers sign up every week, and 40% of those customers are ISVs and startups. We have over 100 data centers across the planet, and more than 6,000 government employees are using Azure right now. So we could say, basically, Azure is the world's computer. But why am I talking about this? Well, we have the world's computer in our hands, and it's still not enough. It's still not enough to solve some of the most complex problems that are out there to solve. If we think about climate change, security, disease control, world hunger, like all these problems require exponential power. When Satya came in, he established a new mission for our company, and the mission is to empower every person and every organization on the planet to achieve more. In the Quantum team, we've taken that mission and we've translated it to, we are trying to solve the world's most complex challenges by developing the most scalable and impactful quantum ecosystem.
We realize that's an ambitious goal, and to achieve that mission, we've launched Azure Quantum last month at our Ignite event. This is the world's first full-stack open cloud ecosystem that delivers quantum impact today. It's an open ecosystem, and so it brings together the world's most diverse set of quantum hardware and software. It's built on Azure, so it brings to it the stability, scalability, and reliability of the world's computer. And as you'll see in the stories of the partners and customers that we talk about later, it is delivering impact today for them, and will provide lasting solutions into the future. So let's dig in a little bit there. To unlock the solutions to some of the world's most complex challenges, it will require a truly scalable quantum system. And to achieve that goal, it will require a vibrant community of companies working together towards that pursuit. We'll need to be innovating across every layer of the stack, from the applications and software down to the cryo controls to the hardware itself. And for that reason, we fully open-sourced our quantum development kit and Q# language earlier this summer on GitHub, giving over 200,000 developers worldwide the tools that they need to learn, solve, and build quantum solutions together. So the nice thing about this is also that using the QDK to write these solutions, our developers that are part of this community can write lasting code and algorithms that run and scale across a diverse set of hardware, whether that's classical or quantum. And then as we see quantum systems grow and mature and scale, Azure Quantum will grow with it, and we'll continue to make available to our customers the most innovative quantum hardware and software currently on the market. One of the most exciting things about Azure Quantum is the partnerships that are part of this, really the backbone of this offering. It's an industry-leading set of companies that have partnered with us to bring their quantum software and hardware from 1 qubit to trapped ion systems from IonQ and Honeywell, semiconductor systems from QCI, and eventually our own first-party hardware will be part of Azure Quantum as well. Each of these solutions has a unique path towards scaling, and part of the beauty of Azure Quantum is giving that choice to our users and our customers to figure out what is going to be best for the solutions that they want to build.
but these partners on Azure Quantum are really small part of our ecosystem. Last year, while we were here, we announced our Microsoft Quantum Network. We announced it with 16 partners back then. And now we have 22 partners collaborating with us in different levels of the stack. We will be adding 2 more this week, J&J and Qubit Engineering. And the way we partner with each one of these partners is really different. Depending on what they're working on, we try to find ways to see how we can collaborate in some part of the stack. We also have customers and affiliates, and Ben will be talking about that a little bit more. And we also partner with universities and researchers around the world. We have our own labs, but we also extend our research collaboration to other labs around the world. We know that to bring impact to our customers and to make an impact in the world, we can do it together, and for us, this is a critical piece. We need to build things that our customers and our partners want to build on top, work with us, and find solutions for their businesses. I'm going to go through a few examples of some of the partnerships that we are working on with the goal of showcasing how unique each partnership is and how very different they are. So last month, prior to our announcement, our Azure Quantum announcement, we partnered with 1QBit and IonQ to solve a chemistry problem for Dow chemicals. Basically, what we did is 1QBit expressed Dow's problem in Q#, and then we took that Q# application and we ran it on IonQ hardware through Azure Quantum. The goal was to find the lowest energy state of the chemical reaction, and you can see that on the black curve over there. We ran it on IonQ hardware, and you can see the different points. I don't know if you guys can see really well from there, but it's the brown, pink, and purple points. And then we also ran it on IonQ simulator to see if the results that we were achieving were matched, and they did. And this was really exciting news. It was a good experiment on near-term hardware. So imagine what we can do when we achieve fault-tolerant hardware. Changing totally gears, also a chemistry problem, but in a very different way. We solve it in a very different way. We partner with OTI Lumionics. OTI builds advanced materials for OLED displays. Basically, what they've done is they've taken their chemistry application to our quantum-inspired optimization solutions on Azure Quantum to solve the electronic structure of large OLED molecules. Concretely, they work on AlQ3, which is a fluorescent material using OLED displays, and they simulated the chemical reaction. The results that they obtained here were much better than what they could achieve with anything else that is out there. And again, this was all based in quantum-inspired optimization solutions that we are bringing to Azure Quantum. They didn't have to spend a lot of money on expensive HPC hardware or quantum hardware. It was all running on Azure. This was a major chemistry milestone, and this type of things will go into production, so this is not experiment anymore. This delivers real results, and it's inspired us to think, what could we do with these quantum-inspired optimization solutions in another chemistry fields, materials development, or drug development? And lastly, a totally different partnership, Zapata, who is also here in sponsoring. Zapata is one of the leaders in quantum algorithms. And you'll be seeing from them, they're going to be talking about Orchestra, their new software platform. We've been partnering with them, we've been working with them so that they integrate Q# into the platform. They say that Q# allows them to express problems in a different way that other languages don't. But not also that, we've also partnered with them so that they add Azure Quantum, our quantum-inspired optimization solutions on Azure Quantum, to their backend. So different type of partnership, and I could get going with the list of 22 partners, but in the spirit of time, I'll give it back to Ben.
Thanks. So the way that we build quantum solutions with our customers and partners is through the Early Access Program. This is a multi-phase framework where we go from problem envisioning to use case identification to prototype and then commercial deployment. I'll share some of the stories of our customers that have been part of this program. I brought some videos to show because I'd really like you to hear it from them directly, but I'll talk through a little bit of the background to set it up. Q2B is always a great milestone for us to come back to and think about what we talked about last time, exactly a year ago. And I recall that we shared some very early results on our collaboration with Case Western Reserve University in revolutionizing MRI scans. Since that time, we've now shared an update to that, and that's resulted in MRI scans that are 3 times faster than the best-in-class techniques that are currently available, and maintaining the same image quality. If you maintain the same scan time, you can turn the knob up and increase the resolution on the image by 30%. You can imagine either one of these options to increase the resolution and fidelity of imaging helps with earlier detection. Shorter scan times can help schedule patients faster so they don't need to wait a month to come in and get a scan. This is making real impact in people's lives today.
This is the aha moment.
If you think about MRI today, the problem is that it takes a while to scan. The other problem is that the MRI scans that we do today have limited sensitivity. So we can see some diseases, but there are other diseases that we can't. Our laboratories developed a new way to do MRI scans called magnetic resonance fingerprinting.
In general, we want to make the MR scan faster and more robust, meaning that we can get good result consistently, no matter where the patient is scanned.
Azure Quantum has really inspired us to look at the future. In every fingerprinting scan, there's actually thousands of decisions that we have to make in order to set up the right scan. Surprising, but the scale of that optimization problem is beyond what we can solve with conventional computing.
Conventional optimization algorithms, typically they have some assumptions. For example, they assume that scanner system is perfect or patient in the perfect position. But in reality, there are lots of confounding factors that may change the signal. If the algorithm does not consider all this, then the result may not be optimal.
We're working with Azure Quantum to use their quantum-inspired algorithms to start to solve these problems.
We provide the question and the target, and they're using their algorithm to help us to find optimal results.
Working with Azure has given us improvement in speed and about a 30% improvement in our precision. The results we're getting are allowing us to see diseases earlier than before and to quantify the treatments that we're giving. Working with Azure Quantum has enabled us to do things that we just couldn't do before. It's really changed the way that we think about MRI scans, and we see a whole new world of possibilities that we didn't before. These results from the quantum-inspired algorithms are going to impact the healthcare of billions of people worldwide.
This is a great story that I love sharing, and so when people ask, when is quantum computing a reality? It's now. The things that we're learning about how quantum computers work as we go down that path are really making an effect in people's lives today. Willis Towers Watson is another early access program member. They are a financial services company that provides advanced analytics tools to their insurance clients for risk management and capital allocation. These are highly complex, nonlinear optimization problems that require a huge amount of compute and time to solve. We're working with them to speed up that process as well, certainly cut down the compute power that they need, and help them deliver results to their insurance clients that allow them to allocate capital closer to real time. And that has a huge effect on their bottom line. Again, I want to share some thoughts from the Willis Towers Watson team on the work that we're doing together.
Willis Willis Towers Watson covers actually an amazing range of services. They're all around, though, the issue of people and risk.
One of the things that sets Willis Towers Watson apart is the use of advanced technology to solve client problems.
Engagement with Microsoft started where we wanted to work with them on the idea of quantum computing, preparing for quantum computing by starting off with what we call quantum-inspired computing today. This is a breakthrough that is going to provide incredible computational power and a different way of really computing.
Risk modeling is a little bit different to classic big data AI sort of problem. With risk modeling, you're trying to quantify the whole distribution of outcomes. It requires quite a lot of specialism, and the prevalent technique is something called Monte Carlo simulation. Simply put, we roll the dice lots and lots of times and calculate from the resulting outcomes.
Quantum-inspired optimization leverages the principles of quantum physics to solve optimization problems in a faster to higher accuracy.
Currently, we can run sort of realistic models in 10 or 15 minutes. If we can bring that down to seconds, then immediately that's opening up the door to real business value.
What this means for the end user is we give them information and insights that they were never able to have before. The limits of traditional computing just meant that we couldn't analyze certain things. With greater insights then comes more efficiency and better choices. I love the quantum-inspired computing partly because of the problems that we're going to be working through with Microsoft today, but perhaps more because of what we'll do in the future. The problems we're tackling today, we'll get some great insights and some great results from them, but there'll probably be things that we haven't even begun to think about today that'll give us future results. That's what's really exciting.
If we could just go back one slide. I think I pushed the button too fast there. John Haley, CEO of Willis Towers Watson, just does a great job of articulating his vision for why he's investing in quantum computing right now. He and his team are learning things about how to approach their customers' problems in a different perspective, and the results from those, the insights from that work, will continue to pay dividends as quantum computers scale and grow. I think Andrew explained why getting that down to minutes or seconds is really critical for allocating capital for their insurance clients. I love these collaborations. This is where the magic really happens, when we bring together the domain expertise from our customers and partners and the real-world problems that they have, and match that up with our expertise in quantum algorithm development, quantum systems, software engineering, and platforms. It's really just a perfect marriage for finding complex challenges that we can solve and derive impact from today. The last thing that I'll share, we announced this morning our collaboration with Ford around exploration of reducing congestion. We ran a traffic simulation, built essentially a pilot of what that would look like with 5,000 vehicles with 10 routes each that they could select from, and ended up minimizing the congestion level, decreasing the congestion level by over 70%, and decreasing the average commute time for that simulated fleet by 8%. This is a really exciting area as well. Everyone likes to brag about why they think their city has the worst traffic. In Seattle, we certainly like to claim that we have the worst, lots of bridges and narrow land, and then you come down here to the Bay Area, everyone will tell you you're wrong, they have the worst traffic. I think the only thing we can agree on is that congestion is getting worse, and so being able to manage this and optimize traffic routing, autonomous vehicles, electrical bicycles and scooters, just moving people. So this is really an investment for Ford in smart cities. I'd invite you to come back again tomorrow to hear Julie Love talk about more details of this collaboration. It's very exciting for us. So those are some of the stories of the partners and customers that we were excited to share with you today. Hopefully you can see how these fit in some of those application areas that you've talked about earlier in the day, and the real-world problems that are able to be solved there.